Hello dear students, welcome to a new session. In this session we're going to continue part 2 of finding the area of some geometric figures. The second figure that we have today is the trapezium, and it's also called the trapezoid. The trapezoid or the trapezium is a quadrilateral in which two sides are parallel. The two parallel sides are called the bases of this trapezium. The other two sides are called the two legs of the trapezium. The trapezium has one height, which is the perpendicular distance between its two bases. Let's now talk about the isosceles trapezium. The following are the properties of the isosceles trapezium. First of all, the two base angles of the isosceles trapezium are equal in measure. As you can see in this figure, if AD is parallel to BC and AB is equal to DC, then automatically the measure of angle B is equal to the measure of angle C, and also the measure of angle A is equal to the measure of angle D. The second property of the isosceles trapezium that the two diagonals of the isosceles trapezium are equal in length. As you can see in the opposite figure, if AD is parallel to BC and AB is equal to DC, then AC is also equal to BD. The third property for the isosceles trapezium that it has only one axis of symmetry, which is the perpendicular bisector of its bases. As you can see in this figure, if AD is parallel to BC and AB is equal to DC, then the straight line L, which is the perpendicular bisector of each of its two bases, AD and BC, is the axis of symmetry of the isosceles trapezium ABCD. And also notice that the axis of symmetry of the isosceles trapezium passes through the point of intersection of its two diagonals. And now, you shall study how to find the area of the trapezium by two methods. The first one, by knowing the length of its two parallel bases and its height. The second one is by knowing the length of its middle base and its height. Let's go to the first way. How to find the area of the trapezium if we know the length of the two parallel bases and its height. The area of the trapezium is half base 1 plus base 2 between brackets multiplied by the height. So in this case, it's half open bracket L1 plus L2 multiplied by h, which is the perpendicular height. So as we just said, the area of the trapezium is half of the sum of the length of the two parallel bases multiplied by the height. The second way in how to find the area of the trapezium, knowing the length of the middle base and its height. Since the length of the middle base is half the sum of the two length of the two parallel bases, therefore the area of the trapezium is the length of the middle base multiplied by the height. So in this figure, the area of the trapezium ABCD is L multiplied by h. Let's now go to exercise number 1 to choose the correct answer. Question 1. The trapezium in which the length of its two parallel bases are 15 and 11, how can we find the length of the middle base? We said that the length of the middle base is half the sum of the length of the two parallel bases. So in this case it will be half open bracket 15 plus 11. Half the 26 is 13 centimeters. Question 2. If the area of a trapezium is 32 centimeters squared and its height is 4 centimeters long, then what is the length of the middle base? We know that the middle base equals the area of the trapezium divided by the height. So the middle base is the area of the trapezium, which is 32, divided by the height, which is 4. So for question 2, the answer is 8 centimeters, which is the length of the middle base. For question 3, the trapezium in which the length of one of its parallel bases is 15 centimeters and its area is 108 centimeters squared and its height is 8 centimeters long, what is the length of the other base? We know that the area of the trapezium, the 108, is half base 1, which is 15, plus the other base, which I don't know that we're going to call it B, multiplied by the height, which is 8. So 15 plus B equals 108 divided by 4. So 15 plus B equals 27, then B equals 12. Let's now move to another type of questions, which is the essay question. In question 1, the area of the trapezium is 180 centimeters squared and its height is 12 centimeters. How can we find the length of the two parallel bases if the ratio between their length is 3:2? As we have the ratio question, we're going to let B1 is 3x, where B2 is 2x. So the ratio, we write x next to each one. So the area, it's half B1 plus B2 multiplied by the height. So 180 is half times 3x plus 2x multiplied by the height, which is 12. So 180 equals 5x multiplied by 6. So 180 is 30x. If you divide both by 30, so x equals 6. To find the length of each base, we're going to substitute x by 6. So it's 3x would be 3 times 6, which is 18 centimeters, where B2 is 2 times x, which is 2 times 6, which is 12 centimeters. Question 2. A piece of land has the shape of a trapezium whose area is 4,000 meters squared. The length of the two parallel bases and its height are having a ratio of 3:2:4, respectively. Find the length of its middle base. So we're going to make base 1 is 3x, where base 2 is 2x, and the height is 4x. So the area, which is the 4,000, equals half base 1 plus base 2 multiplied by the height, which is 4x. So the 4,000 equals half times 5x times 4x. So 4,000 is equal to 10x squared. So x squared is 400. Then the value of x is 20. As long as we got the value of x, so B1 is 3 times 20, which is 60 centimeters. B2, which is 2 times 20, which is 40 centimeters. H is 4 times 20, which is 80 centimeters. The question is asking you to find the length of the middle base. So we know that the middle base equals half the sum of the two parallel bases. So half times 60 plus 40, so the middle base is 50 centimeters long. Let's now move on to the evaluation part. And please, when you see the question, pause the video, try to answer the question yourself, then play the video again to check your answer. Find the area of each of the following figures by using the given data. So here in question 1, we have given the two parallel bases, but we don't have the length of the perpendicular height. AB is the same as DE. If this is a 45 and this is a 90 degrees, so this is a 45 degrees. If this AD is 7, so EB will be also 7, then CE is 5. So if this is 5, this one will be also 5. So the height now is 5. So the area of this trapezoid is half base 1 plus, take care that the base 2 is the 12, multiplied by the height. If you do your calculations, it's 47.5 centimeters squared. Question 2. We have here, this is an isosceles trapezium or isosceles trapezoid. So what we're going to do, if we make a perpendicular line in here, let's call this point E. So this is the 30 degrees. Isosceles, then CD is 10 centimeters. So automatically CE will be 5 and DE will be 5 square root of 3. If CE is 5 and we make another line in here like this, another perpendicular line, so this will be 7. So for sure this one will be also 5. So the area of this trapezium will be half the two bases, 7 plus 17, which is 5 plus 5 plus 7, multiplied by the height, which is 5 root 3. If you do your calculations, the area will be 60 square root of 3 centimeters squared. By solving the two questions in the evaluation part, we reached the end of our session. Thank you very much and wishing you best of luck.